This is the 2018 Ordinary Level Section A. So I'm going to go through each of these, each of the 4 questions. There's 4 questions presented. You need to answer 3 of them. You answer them on the sheet. So I'm going to go through each one of these here now. Question A1 is a conics question, and there's also a bit of work in there with an arc. So just reading through the question, A1, 3D graphic below shows the proposed design for the new Children's Hospital in Dublin. It consists of an ellipse and 2 inner circular arcs. The drawing on the right shows the major and minor circles. So major circle, minor circle. Portions of the ellipse, this and the inner arcs are shown. So they've done one, and we must complete the other one. Look, so first part A, locate the remaining points on the ellipse and draw the curve. Part B, locate the focal points of the ellipse. And part C is locate the center point of the lower arc and complete the drawing. So they've started this question for us for the curve around, for the ellipse around the outside. We're using our auxiliary circles method. So we've got a line coming out from the center here and then 2 other lines from there. So I'm going to continue that. So they've taken probably 30-degree line, which it is. So I'm going to extend that line out the other side, and I'm going to divide this, the major and minor auxiliary circles up with my 60-30 degree set square. You can use any angle you like, but 60-30 is handier. Just keeps it all fairly consistent. So this is our circle divided up. And from each point, so I'm going to take each line in turn. So if we take this line here first, and this line cuts the major auxiliary circle at this point and the minor auxiliary circle here. So my rule for this is this line cuts the major auxiliary circle, so I'm going to go perpendicular to the major axis. Major axis is running along this way, so I'm going to go perpendicular to the major axis is going to be the line along here. This same line cuts the minor auxiliary circle at this point, so I'm going to go perpendicular to the minor axis for that one. That gives me a point in the curve here. Next point in the curve is going to be the end of the minor axis, so that's where the minor axis intersects the minor auxiliary circle. Going to do much the same now on the opposite side, so this line here cuts the major auxiliary circle at this point, going to go perpendicular to the major axis, that's down this way. Same line cuts the minor auxiliary circle, that's this one, perpendicular to the minor axis, comes along here. It's a point on the curve, and doing the same thing with this one over here. Another point on the curve. So down the bottom it's the same. This this line cuts the major auxiliary circle perpendicular to the major axis is there. Perpendicular to the minor axis from that one. And that gives us as many points on the curve as we need. So we've got just this one here as well. So then drawing the best curve that you can. Joining all of these points up. And that's our curve. We might need to darken that in a little bit more. So that's part A, that complete. Part B, this is to look at the focal points of the ellipse. So the focal points are found, there's a relationship between the focal points and our ellipse. So the distance from the focal points to any point on the curve and back to the other focal point is equal to the major axis. So what we can do instead is if we take half the major axis, so measuring half the major axis here, so from the end to the center, point my compass onto the end of the minor axis and swing an arc so that it cuts the major axis. We'll cut it in 2 places, here and here. They are our 2 focal points, and make sure you label them F and F1. Okay, just make sure you label them as focal points. And that's part B of this question. Part C of this question is to locate the center point of the lower arc and complete the drawing. So we've got an arc, this one up here, this is going to be another one down along here. And now this is symmetrical, so what we can do is we're going to flip, we need to find that point, so this point down here, down on the other side. So you can do that a couple of ways. You can measure it with your set square or get your compass and swing that around, so taking this distance here, copying that onto the other side. So that's now the equivalent point down here. Now we're not freehanding this, we're just trying to find where that point is down there. So what we're going to use is we're going to use chords. So chord is a line that touches 2 points on the circumference of a circle. That's going to pass through the inside of the circle. We already have one chord, so if we're looking at this top arc up here, from here to here, that's one chord. It touches 2 points on the circumference. A line, if you bisect that line, so halfway along that line, you get the bisector, and the bisector contains the circle somewhere, or the center somewhere on it. If we take another chord, so if we were to take this one, so from here to this point, and bisect that line, we get another chord, another bisector, and where that bisector intersects the first bisector is going to give us our center. So we already have this first one for this bottom curve. So this line along here, so from there to there, bisected, so our center point is going to be somewhere along this middle line. Taking the next point, this line to this line, and if we can bisect that one, so just extend over halfway, swing our arc. And there's our bisector, which puts the center point for our arc just up here. So point for compass on that point where it crosses the minor axis onto the other side now as well. And we can draw our arc in here. And that completes question A1. Question A2, 3 stone containers for growing flowers are shown in the 3D graphic below, so 1, 2, and 3, ABC. The containers are in forms of geometrical objects which are in contact as shown. The drawing on the right shows the elevation and partially completed plan of the objects. The arrangement consists of a cylinder, a truncated cone, and a hemisphere. So a cylinder, a truncated cone, and a hemisphere. Part A is to draw the plan of the cylinder B, and part B is to draw the plan of the hemisphere C. So starting with the cylinder, we can see here that it touches off just at a single point. That's important. That means that the center for drawing this circle, or what it'll be, circle and plan, is going to be in line with the center of the circle for this cone, or a truncated cone. The reason we know that is if this was not in line with it, if it was further to the back or further to the front, there would have to be hidden detail here, so this is in line with it. Okay, so the center is going to be somewhere out along here. Our center is going to be directly below where it is in the elevation, so this is going to project down this way. And the width, or the diameter, will stay the same as well. So we can take down this line off over here to the side. So distance from here to here is going to be the radius. So with your compass, we're just going to swing an arc. So darker on the outside, but then we have hidden details. So this bit here is under, so part of this here is going to be hidden underneath that when we're looking down on top. So hidden detail, broken line in here. It's important to put that into it. Next part of this then is the draw the plan of the hemisphere. So again, in plan, this is going to look like a circle. Now this one we can see is not in line with it because it's not touching it like this one was, and there's hidden detail, so it's blocking some of it. So it's going to be down here somewhere. So we need to find where that is first. But before we can do that, we can't just draw it straight down here. That won't work. We're going to have to draw this as if it was in the position where it's just touching off the side of it. So we're going to have to essentially move this off over here to the side a little bit. So I'm going to redraw this in its position as if it was in line here. So we're going to do that first. So to do that, I'm just taking the radius distance here and measuring that off out to the side there. So you don't need to draw this part of it in, but you do need the construction first. So we need to know where this center is. Okay, so that would be the center of this hemisphere if it was in line with this. So we're going to draw that down here in plan again. So taking this, projecting this point down here, and you could draw the hemisphere here and you'd see where it cut through it under there, so it's kind of hidden underneath that. That's not our final position. So this is it in the position here at the side. We need to rotate this into its final position, which is going to be down here somewhere. To find where that center is, going to take the final center, so the dotted line here for the hemisphere, the red one that they give us. Project that down, and I'm going to rotate the center. So this is the center in the moved over position. We need to rotate this around now until it's in its correct position. So taking that distance, so taking this distance, or swinging this around until such time as it cuts the correct position. That gives us the center of what we're looking for. So taking this point, so compass, again, same distance as what it was up here. I'm going to draw this. There it says. Apologies, I used the wrong size radius up here. So taking this distance, so same distance as what we had a while ago, and then on our point here, rotating this around. Again, we're going to have some bit of hidden detail where it goes in underneath it. And that continues the rest of the way around there. Okay, question 8.3 is a perspective question. There's a lot of it set up for us. So we've got our picture plane up here, our spectator, so all lines are going to have to join to the spectator. Where they cross the picture plane, we bring them down along this way. So you're probably going to need your sliding set squares for this. An adjustable set square, use that. So taking your lines, projecting these down along this way. So everywhere a line joins the spectator where it crosses the picture plane, that's the line that we're taking. So everything comes parallel then down along this way. So taking that, this one comes down to here. Where it hits this line going back, that's a point on that. So again, this is just taking all of our lines down along. So this one's going to come down along, and where it meets this one coming across is the point that we're looking for, which will then join to the first one that we found, giving us that. Kind of a line coming across this, because there's a change in direction. I have the same, something similar inside, so we need to find where there's going to be a line coming up along there, where that is, where does that go to? So taking, now we've also this little line down here that we can darken in. So we need to find a point inside here. So that one is going to be done the same way. So taking this point here, joining it to the spectator, gives us that one. Where it crosses the picture plane is a point up in here. So taking that point, projecting that down until it touches the ground, that gives us that point. So that's the start point. Now we need to know where it ends up. So it's going to be up in line with this here somewhere. So again, taking this point, now this one, joining to the spectator, or crosses the picture plane, going parallel to all our other lines down along this way. And we're going to need to join this line, so this point off over here down to VP vanishing point 2, and that's this point. So that is going to draw up to there and disappear behind that. So that completes this drawing. So we were just asked to complete the perspective. You could also find this point in here by taking this point and joining it back to the vanishing point 1, where we'll cross there, will give you the same. But lots of different ways of finding different points with this question. Okay, final question for this one is question A4. The image below shows a concertina. The instrument is hexagonal in cross section. The plan elevation and the partially completed end view of the instrument are shown. So there's two parts to this question. Part A is to complete the end view, so which is this view over here. We have the elevation plan. This is the end view. And part B is then to draw the true shape of the end of the instrument. So we're going to be taking an auxiliary view. So starting with our end view, they've done some of it. So they've taken lines across here and rotated them up. If you're more comfortable doing a line here at 45 degrees and bringing all your lines over and up, you can do that. Or you can take your lines up at 45 degrees that way, whatever works for you. So taking this line across until it, so this point, taking this one across, and we're going to rotate that now up into the end view. Rotate it around. So let's rotate that and then project that up. So this point here, just follow it up into the end view because the heights are going to stay the same. It's going to be this point, which is a point on the ground. So that's there. Follow it up further. It's this point, which will be this one up on top. So the heights stay the same. So that's that point there. Next one is going to be doing this point. So taking this one over, rotating that around into the end view. So that's this point. So find that point now in the elevation. So that's going to be here. The heights are going to stay the same. So I'm going to project this one across. That gives me that point there. So looking in this way, I can see that. So this is a dark line here and here. So that's the visible part of the end view complete. Now we have the hidden detail bits that we need to do. So we have some of it there. Now we've got two other points, this one and this one. So doing both of these. So I'm going to take the bottom one first, taking that across. That rotates. So it's always rotating around this point. So we're transferring it into the elevation, or into the end view. So that again, so this one, find that in the elevation. So it's going to be on the ground. So it's this point here and this point up here. So those two. And finally, this point here rotates. It's going to be up along here somewhere. So this one is going to be this point here. So it's in the middle. So following that around, that's this point here. Now it's, when we're looking in from this side, I can't see it. So it's a hidden detail line. So it would be going up along, broken line along here and the other way. Technically there's hidden detail there, but we can't see it because there's a visible line, so we don't need to worry about that. So that completes part A of this. So complete the elevation, the end view as we were instructed. Oh, sorry, it doesn't. There's one other bit, which is this back edge. There's a back edge running along here, so kind of like one of them, and that's going to go from this point to there. So that's a hidden detail line running along here. So that's the end view completed. So final part of this now is we need to find the part B, draw the true shape of the end of the instrument. So this is this here. Is this at 60 degrees? It is. Good. So this is at 60 degrees, so we're going to look in perpendicular to it, so we're going to take an auxiliary. So we're just going to project all our lines perpendicular out along here. So projecting these out along this way. We've got 6 points that we need to locate. I'm going to keep this stuck on the object here just because we have a bit more space. So this is 1 and 2. They're on the ground. So that's 1 and 2. So we're going to be measuring our distances. So this is an auxiliary view. Skipping this view, measuring from this view. So this one and this point there on the ground are next to. So if we take this one, how high is up is that? That's this height. So I'm going to measure this height up off the XY line. That gives me this height here. I'm going to copy that height up here. So here, same for this point on this side, so we can measure that one up. So we now have 4 points, 1, 2, 3, and 4. Final 2 points then are going to be these two. So they're up at this on the same line up there, up along here somewhere. Measuring that height, 1 and 2. So joining these up. That completes part B of that question and completes the 2018 ordinary level section A.